Alright, we are back, and hopefully the camera is going to play nicely this time. I don't know what it is with me and webcams, but I have never owned a single one that was even remotely decent. Um, let's hop right to it instead of testing our luck with this. If you remember from, let's call it about 10 minutes ago, we actually created the file we need, but since I like to do these in one take, let's clear it out with our usual echo command. And we will jump right into it. Alright, we are going to need standard IO.h, standard library.h, and time.h. Time.h works with the rand function to seed it. Main's always going to return an int. It's always going to take an int argc and a character double pointer argv. And don't forget to return 0. Ooh, got some silly fingers there. Alright, if we are going to use random, the first thing we're going to want to do is take the current time, which you can get from the time function. If I remember correctly, the time function will return, I believe it's a long integer that represents the current number of seconds since midnight 1970, January 1st. That was an awkward way to say that. January 1st, 1970, midnight, the start of the day, I believe. And the brain fart. The argument that goes into it is a pointer to a long integer where that will be stored, and that long integer itself is also the return value. You can also just throw null in here and it will work just fine. Since we're not going to store it, we don't have to worry about any of that, but we are going to use it for the srand, seed random function. That'll go ahead and make sure that our random function is returning, let's go with functionally random numbers in case there's any pedants in the audience. The rand function is deterministic, and it will always return the same sequence of values based on what you put into srand. So the way you get around that is you pipe the current time into srand, and then it is random enough for most purposes. We're going to need this to scramble up our array that we are going to sort with our bubble sort function. Alright, that was fairly long-winded and didn't get us much of anywhere, so let's go ahead and make our array. We will call it and let's just go ahead and make it, I don't know, 50. Maybe we don't want to do it that way. Make a variable called buffer length, and we will set it equal to 50, and we'll use bufflen here. There we go. And we don't need to do that. The for loop's a little more readable if you go ahead and include the variable initialization there. I'm a big fan of weird for loops, but they are difficult to read, so we'll be nice to our future selves. So, bufflen, and go ahead and increment I each step. Sort I will be equal to rand. Rand is going to return us a random variable between 0 and rand underscore max, and rand underscore max is some sufficiently large number. We could figure out what it is, but it's not really important for our purposes now. Alright, and then I think what we're going to want to do is go ahead and printf Ooh, almost forgot that semicolon. That could be wild. Printf. Printf. Oopsie. That one. Then that one. This is gonna need quote marks anyway. Is, and then we'll go set D. Then we just want an I and a two sort I. Should do the trick. Do we need? Yeah, these are both unsigned, so we should make these unsigned in here. All right. This is something we haven't done a lot in our shorter programs, but I think we're going to compile and test in the middle because we're crazy like that. Because we want to know if there's a problem now. Right. Usual GCC line, force our ANSI compliance, specify our output file, and our input file. That should do it. All right. See, it already found something for us. Forgot a semicolon. Go ahead and rerun that compile. Seems to have worked. And there we go. 50 random numbers. Look at them go. Cool. Alright, now we're going to need to actually code bubble sort. And it's occurring to me that I think what we're going to want here is a paint file. I wonder if Linux includes a drawing program that we can use easily. I can go ahead and take a look at it. LibreOffice Draw? Never used LibreOffice Draw before, so forgive me if this goes crazy. What on earth is that? Something I was using for something. Crazy. Alright, this already looks like it is beyond what I want to deal with, so I'm going to go ahead and get rid of this. I'm sure LibreOffice Draw is a perfectly fine program, but we're going to go ahead and open up Paint, and I think if I do this, do that, there we go, MS Paint. Alright, so we want a little description of how bubble sort's supposed to work. Should probably have this in the dark theme. Let's just go ahead and do that. Come on. There we go. There we go. Now the screen's at least mostly black. Okay, so we're going to have an array of numbers. How about a 6, a 12, a 5, 32, and 4. That was very important, 4. So the way bubble sort's going to work is you're going to go through your array here, and you're going to examine each pair of numbers and compare them to each other, and whichever one's higher, you're going to swap up the list. So the first thing you're going to do is you're going to take this 6 and this 12, and you're going to compare them. Since the 6 is smaller than the 12, you're not going to do anything. Then you're going to compare 12 and the 5. The 12 is higher than the 5, so you're going to swap them. You're going to swap them, and you're going to look at the 12 and the 32. These two are in order, so you're not going to do anything. And then you're going to compare the 32 and the 4, and because the 32 is larger, you're going to go ahead and swap them. Now at this point, you know for a fact that this 32 is in the correct place, because each pass, the largest number will make it to the top. That is where the name bubble sort comes from. So, you can sort of decrease the amount of comparisons you're making each time you pass through the whole list. Let's go ahead and get that up there again. 6, 5, 12, 4, and a rock solid 32. And we go ahead and erase. Oh, come on. Go ahead and kablamzaloid. Jeez. Alright, there we go. Drag a big old rectangle over them. Come on! An awful solid color. There we go. Mere rectangle. Really? Solid color? Please? Huh. Okay. Why doesn't this want to work for us? Okay. Okay. There we got it. Thanks for bearing with me, folks. Okay. Back to the actual algorithm, you are going to, once again, compare the 6 and the 5. And swap them, because the 5 is smaller. And then you compare the 6 and the 12, and you're good to go. You're going to compare the 12 and the 4. And you're going to go ahead and swap them, because they are out of order. And now you know that these two are in the correct place. And you will go ahead and continue on, so on and so forth, as they said back in the Army days. These two still being rock solid. Rock steady was like the Ordnance Corps motto, I think. 5 and 6 are good. End up comparing these. 12, 32. These are solid. And you're going to go ahead and swap these. That is a terrible 6. I'd fix it, but MS Paint has a fun way of making anything you try to fix look terrible. And then you're just comparing the 5 and the 4 at this point. And you swap them because you need to. And voila, the list is, wow, that did not come out good, 32. The list is as sorted as it's going to get, i.e. fully sorted. Hurrah! And that is the general overview of how the bubble sort algorithm works. We'll get into the niceties of it when we swap back to our actual code, which is right over here. Handy. So, I like to have everything always return an integer. Let's go ahead and call it bubble sort. And it is going to take a unsigned int. To sort. And we're going to need to know the size of it. let's go ahead and call it last index. Those are fairly long variable names. It's always a balancing act between how much you want to type every time you use a variable versus, you know, how specific you want to be in naming it. So, we are going to want to loop through a data structure in a sort of nested fashion, if you notice there. I and j seem like fine variables. I is going to start at 0, and we're going to run this as long as I is less than last index, I believe. And I'm just going to go ahead and increment each time. We're going to have a handy-dandy nested for loop. Something I completely forgot. You will notice that one of the things we did fairly frequently was swap two integers. So we're going to need a function, or in this case, a macro, that swaps two integers. And we're going to use a handy-dandy algorithm called the XOR swap, because it's cool, and I like it. A XOR equals B, that performs a bitwise XOR and assigns the result of it back into A immediately. B, put it in parentheses, folks, going to XOR equal A, and A is going to XOR equal B again, and those. I don't think we want that. That makes everything quite confusing. But we are going to want the parentheses just in case something comes up with the order of operations. Parentheses are very handy. Alright, so this takes advantage of the fact that when you run an XOR on two values, you don't actually lose any information. It's very easy to get the originals back out. So our first line here, A is going to be equal to A XOR equals B. Infuriating. Let's go ahead and restart that. You're going to have A XOR B stored in A, and then you're going to have the XOR of that with B stored in B, which is equal to A. So you've got A, what was originally A stored in B at the conclusion of this step here, and then because you have A stored in B, you can pull B back out and it'll store it back into A. Feel free to look that up on your own time. We're not going to spend a lot of time on it here, but it does work, and that is the logic behind it. Back down to our actual bubble sort algorithm, we are going to want to start J at 0, I believe. And J is going to need to be... Oh, what was the logic here? I just wrote one of these. J is going to be less than last index minus I, believe, because we're going to compare the jth element and the j plus 1th element, as awkward as that is to say. And as long as we stay below the last index, then we won't run into any overflow situations. And I believe we just do a j++ here. I think that is the secret. And then, if toSort j is greater than toSort j+1, Haha. We will. This actually threw me for a loop last time I wrote one of these. You do need these braces because this macro here is multiple lines of code. And it will give you strange, strange garbage if you don't remember to do that. J2 sort J plus 1. And I rigged this up so you do actually need to put the semicolon on the end. It looks a little strange up here, but when you put it in line, it looks, you know, more natural. All right. That is certainly infuriating. We are not going to coffee. Wow. Technology is not my friend today, but I've been sick for a week, and I want to get one of these out just to keep up. Okay, so I think what we want to do now is bubble sort it. And the last index is going to be bufflen. Aha, 1f. -1. And we'll just go ahead and compile that and see if we get any issues. Plenty. All right. Unterminated argument list invoking macro swap. Swap undeclared. What do we call it? Define swap AB. Yeah. Aha. That's why we test, folks. Alright, and that seemed to compile without error. My webcam's still going. We got like 5 whole minutes out of this. That's actually pretty good. And we can go ahead and run it. We're not going to see anything too interesting. It's roughly the same output as before. Nano bubble sort.c. And I think what we'll want to do is we'll just... 50 is a bit big. That was a bit saucy. We'll just do 10. Okay, and we are going to go ahead and print off the values. Unsigned integer is %u, another unsigned integer. Behold the sorted list! Exclamation point. Put new lines on either side of that. It'll make sense when you see it lay out on the screen. You start to get a sense for where you need new lines to make stuff look right. And that's going to go ahead and be I, and that's going to go ahead and be to sort I. And that should do it. Let's see what we get. Compile and run. So there we got 10 random numbers, and we have apparently, sure looks like we've sorted them correctly. Ta-da! That is bubble sort, folks. I think next time I want to start doing heap sort would be a good one. I'm going to need to spend some time in practice before we get going on that because it is kicking my ass currently. We might actually have kind of a different format where I just muddle my way through it on camera. That'll be fun for you guys to get to see me get mad at the code and stuff. But for now, that'll do it for Bubble Sort. I hope you all learned something today, and have a great day.